Hi, my name is André Coroado and I'm a physics engineering student at Instituto Superior Técnico in Lisbon. I'm here to present you my master thesis being developed at the Theory and Modeling Group of IPFN. Fulfilling the human need for energy is one of the biggest challenges mankind is facing today. In attendance to the fact that fossil fuels still represent the main source of energy supporting global consumption, this is a urgent problem, since fossil fuel reserves are not expected to last more than a few decades. Moreover, fossil fuel burning is responsible for increasing the greenhouse effect, which in turn leads to climate change and the rising of sea level. This is why alternative solutions must be found right now. Nuclear fusion can be that solution. It is expected to provide a clean, safe, long-term source of energy, while revealing promising perspectives as very high energies are released in nuclear fusion reactions. The idea is to reproduce fusion reactions taking place in the Sun, which is continuously burning hydrogen to helium. Nowadays, the main reaction under investigation is this one. It features two different hydrogen isotopes, deuterium and tritium, combining into an alpha particle, which is the most common helium nucleus, and a neutron, releasing energy as gamma rays in the process. In order to do this, we need to fight against electromagnetic repulsion between positively charged nuclei, bringing them together to make fusion a reality. While the Sun does this by means of its own gravity, we have to find other strategies based on heating fusion fuel to very high temperatures, about 10 times the inner solar temperature. At these high temperatures, fusion fuel is ionized, thus creating a plasma. However, in order to keep those high temperatures, the plasma must be confined. Usually this is done by magnetic confinement inside a toroidal magnetic chamber, that is to say, a donut-shaped reactor, which we call a tokamak. Indeed, a helical magnetic field is imposed by means of external magnetic coils, thus confining the charged particles of the plasma. Now, we intend the reaction to occur in a self-sustained way. This requires the energetic fusion-born alpha particles to play a major role on heating the plasma, thus keeping it at high temperatures with no need of external heating. This means alpha particles must remain confined to the core region of the reactor where they are meant to heat the plasma. Additionally, they shall be prevented from reaching the outer region as they could damage the reactor walls due to their high energies. Therefore, alpha particles confinement really is important. Of course, this shall not be a problem, as they are charged particles and so they should be confined by means of the magnetic field. However, the magnetic field lines are oscillating in the plasma instead of being static. These oscillations are known as alpha waves and they propagate at a well-defined velocity known as the alpha speed. The problem is that fusion-born alpha particles usually move with velocities close to the alpha speed, thus giving rise to wave-particle resonant interactions. This may lead to energy being transferred from alpha particles to the alpha waves, thus driving them unstable. Now, you can easily imagine that if the magnetic field lines confining the alpha particles have unstable oscillations, then the alpha particles confinement will be at risk. This is why it is so important to study the resonant energy transfer from energetic alpha particles to alpha waves. Several research projects on this subject have been carried out recently, and numerical simulations have helped to achieve important breakthroughs. However, gross analytical estimates led to a puzzling conclusion. The alpha particles that contribute the most to the energy transfer have velocities almost twice the alpha speed. How to solve this apparent contradiction? That's where I come in. I will perform systematic analytical studies on the alpha particles' resonance in order to obtain a rigorous analytical form for the resonance condition. By interpreting the terms involved, I shall identify the physical mechanisms governing the resonant energy transfer, thus gaining physical insight on what's really happening. This shall reveal the answer to the apparent contradiction I have just mentioned. Moreover, it will also provide clues on the optimal parameters, maximizing or minimizing the energy transfer from alpha particles to alpha waves. Increasing it shall be important for experimental research purposes, while reducing it will be a key factor towards a good performance in fusion experiments. This is the challenge I'm ready to take. Feel free to contact me if you want to know more about it. Thank you for watching.